So I'm going to go through page 2 of the Polar's Test Review Guide. Here we're changing rectangular equations to polar equations. Now at the top you can see our 4 conversion equations. So first we've got y equals -2, and our goal is to write this equation without any x's and y's in it, but only r's and thetas. If you look up here, we have the equation y is equal to r sine theta. So we can plug in r sine theta, where y is, and get the equation r sine theta equals -2. To solve for r, you would divide sine theta to the other side, and now you have r equals -2 sine of theta. That would be one correct answer for that problem. Another way to write it would be r equals -2 cosecant of theta. That's just recognizing that 1/2 sine is the same as cosecant. Either way is an acceptable way to write the answer. For b, we're going to use the same strategy we used in a. We know that x is r cosine theta. We know that y is r sine theta. We notice that each of these terms on this side have an r in it, so we can factor out the common r from both of those terms. This is a good idea because now we only have one r in the equation. And now if we were to divide this parenthesized term to the other side, we'll have r equals 8 over 5 cosine of theta minus 2 sine of theta. And that would be our answer. For the third problem here, we've got 2y equals x squared. We're going to use the same strategy again. 2y is 2 times r sine theta. And we know that x is r cosine theta. Oops, that shouldn't be a plus, that should be an equals. So x is r cosine theta, but notice that I put the r cosine theta in parentheses because on the right side we're going to have to be careful. When you square out a term like this, you have to square out each individual part of the term. So that'll give us r squared cosine squared. And now what's interesting is both terms in this equation on the left and the right have an r in it. So we can go ahead and divide both sides by r. And on the left side, that's going to give us just 2 sine theta. On the right side, that'll only leave us with a single r cosine squared theta. And now if we divide cosine squared to the other side, we'll have r is equal to 2 sine theta over cosine squared theta. Okay, last one of the rectangular to polar equations. Notice that we have x squared plus y squared, which was one of our equations. It's r squared. And 6x, we know that x is r cosine theta. And very similar to the last one, we could actually add the 6r cosine theta to the other side, which would enable us to divide both sides by r. And so r will equal 6 cosine of theta. So that's the rectangular to polar example problems. We're also going to look at going from polar to rectangular. So for A, what we could do is square both sides, which gives us r squared equals 100. And the reason you want to do that is we know what r squared is equal to. It's x squared plus y squared. And we've accomplished our goal. The equation is now in x and y's. The next equation, you don't want to square both sides, even though it looks like that might be a good idea, because you end up with cosine squared theta, which we don't really know what to do with. But if you were to multiply both sides by r, you'll get r squared equals -2 r cosine theta. And that's useful because r squared is x squared plus y squared, and r cosine theta is x. So this is a good answer. If you'd like to add 2x to the other side, that's fine too. For C, it might be helpful to look at a problem similar to it. So that would be up here. 5a, we had r equals -2 cosecant theta. And I'm going to kind of go backwards here. If you look at what we started with, we went to r sine theta, then we went to sine theta divided to the other side, and then we rewrote it as a reciprocal function. So if we go backwards, we would have to go from the reciprocal function to having the trig function on the bottom, to multiplying sine theta to the other side, and then using one of our conversion formulas. So we're going to do that down here in 6. 6c, we are going to rewrite this as 5 over cosine theta, the reciprocal of secant. We're going to multiply the cosine theta to the other side, and then we know that r cosine theta is x. D is the same also, 6d is the same as 5d. I'm sorry, 5b. If you look at 5b, we end up with this sort of monstrosity. If you go from this step backwards, you'll notice we've multiplied the denominator to the other side. We then distributed, and then we replaced r cosine theta with x and r sine theta with y. We're going to do that down here then. So we're going to multiply the denominator to the other side. We'll have r sine theta minus 5 cosine theta equals -3. We'll distribute. And then r sine theta is y, r cosine theta is x. And then if we add the 5x to the other side, we get this very nice linear equation. And that's it for page 2 of the Polar's Test Review Guide.